What do you think this anterior part is that was normally clear, but it's kind of now becoming a little opaque?
Cornea.
That's the cornea, and again, it's becoming opaque because of the formalin, right? It's been in the preservative for so long, and then the fibrous white, which actually there's some additional tissue here, but this even under that very fibrous tissue right there, very hard. That's the sclera. Okay, so white going all around, basically right up to the cornea. Now, in some areas, you may also see some pigmentation. See this? Okay, remember, these animals are outside in the sunshine the entire time. It's not like they can have the rancher come by and put on some sunglasses or put a hat on them. So this is their body's way of protecting the delicate eyes a little bit by depositing some melanin around the eye to absorb some of that energy. Okay, as I mentioned already, notice all the fat. Very well protected within that bony eye socket. Lots of fat here. I'm going to cut a lot of this fat away. And there's also some muscle back here. So let's see. Let me find the nerve first. I don't want to cut into the nerve. Sorry, it's making some crazy noises, huh? There it is. I know it's that's the first tendency to think kind of nasty, but look at how important your eyes are. You should be thanking your eyes right now for everything that your eyes enable you to do.
Kind of want to smell when it's dinner time.
Does it smell to you?
It's dinner time.
They eat them on Survivor, don't they?
Mm-hmm.
Okay, I'm going to clear as much of this. And you guys cut as much of the adipose as you want as well in your eyes. I mean, your cow's eyes. I'm going to cut it so you guys can see the nerve as well as you can. Now, you can see how dark brown this muscle is? It looks like me. It's muscle. It's skeletal muscle. So that's been exposed to the preservative for a while. Now, if you look deeper, where it was kind of hidden away, this is a little redder, a little pink, so it hasn't been in touch with the preservative as much. Okay, that's why it looks fresher like that. But these muscles are any of those extrinsic muscles. Do we know specifically which one? I couldn't tell you what's top and what's bottom here, so no. But if I have one of those muscles pinned, you need to identify it as an extrinsic muscle. Okay? And I'm just going to, again, clear the optic nerve just a little bit more so you guys can see it.
Is it extrinsic or extrinsic rectus muscle?
Now, we don't know if it's a rectus or if it's an oblique, so extrinsic muscle is fine. We can assume that it might be a rectus because there's at least 4, but we cannot be definitive in that. Okay? And there's the optic nerve, what I'm grabbing it from. That's the optic nerve. I'm sorry. Here you go. Let's do it with this. Okay, so notice it's coming out the back of the eye. This optic nerve would pass through the optic canal or optic foramen of the sphenoid bone and go straight to the optic chiasma. Okay, and again, extrinsic muscle there. All right, going back to the front, what you want to do now is you want to grab your scalpel. I know students love to use scalpels, and we usually say no, no, and I'm guessing there won't be a whole lot of fluid in there because I see some fluid here. But you want to go just behind the cornea, just a few millimeters behind, just like this. See where I am? And make that first cut, but don't do it in the air like this. Set it down and have the scalpel go into the tray. That's why they have this rubber piece here, okay? Just make that first cut. I'm going to squeeze it a little bit, see if any more fluid is in there, but I think most of the fluid has come out. But that would be, there we go, that's some aqueous fluid there. That's in the anterior and posterior chambers, okay? Now again, I've been squeezing this one. Yours may squirt. If you feel a lot of pressure there, it may squirt, so be careful. Always point it downwards. Then you take your scissors and you go into that incision and just cut around. You hear the crunching? Mm-hmm. That's the sclera. Okay, that's the sclera. So you see how tough it is. In fact, sclera does mean tough. All right, so I'm going to remove the anterior. Try to get the lens here too. Hold on. Don't peek yet. I want y'all to be surprised with how this would be. So it should look like this, okay? The anterior. So what you're seeing from this point forward is the lens. It's attached to that ciliary body here, or the ciliary muscle. Then we remove the lens, and normally there would be a lot of little suspensory ligaments, but unfortunately this wasn't done perfect, so you can't see them. But maybe on your own you might be able to see them. Notice it is very opaque now. This would normally be transparent. Okay, so y'all can clean it. Y'all can try to set it on your piece of paper. I don't know if you'll be able to see through it. You want to save the lens. While you can throw all that away, you want to save the lens. Now, there's almost like a step down from the ciliary body, which looks like the bottom of a mushroom cap, to a smooth black structure. That is the iris. And you might want to make a note that the iris is immediately around the pupil. This is a very dilated pupil. It's also oval and not round like ours would be. Okay? And then the space that's in front of the iris, that would be the anterior chamber that had that aqueous fluid. What you can do is you can also come from the front and you can remove the cornea. So just pinch it a little bit, make a cut right at the edge there. And then put your scissors in and just cut all the way around. And then you'll be able to see the iris from the front. Okay? So I'm just going to kind of go halfway around or so. Okay. So now this is the iris from the front, and that hole is the pupil. And the space here, notice how this is now kind of curved. That space there is the anterior chamber. Okay? That would be filled with a fluid. So keep this as well. Now going to the posterior part of the eye, see what looks like jello in there, but like a watery jello, very fluid jello? That is the vitreous body. Okay, I'm going to see if I can get it out without damaging the retina too much. That's it. I'm sorry. I'm sorry. There it is. That's the vitreous body. That helps maintain the shape of the eye. It pushes the retina and the choroid against the back of the eye. Okay, I know it's going to be tough to see, but I'm going to point it out to you guys here, and I'll try to go all the way around. Do y'all see where the retina kind of puckers? And by the way, the retina is that beige, the very thin beige structure. Do y'all see where it kind of puckers a little bit right there? That is called the optic disc. That's where the optic nerve exits from the back of the eye. Okay, I say it looks like it's puckered, and that's kind of a good hint there. Okay, can y'all see? I don't know if you can see. That's the blind spot. That's the optic disc, correct. Okay, I'm going to actually pull the retina because I want y'all to see the 3 layers. So this is the retina being pulled here, okay? And it's going to get torn. It's very delicate. Okay, this beige, very delicate tissue is the retina. I'm going to hang this upside down. Notice that the retina is still attached at the optic disc because that's where all those neurons are going to exit to become the optic nerve. And then the next layer, as we move outwards, the next layer is again the choroid, which is normally very dark. In fact, in humans, it is going to be a dark, dark brown, almost black. So I'm pulling it away from the sclera, okay? That right here, that tissue is the choroid, what I'm holding on to, what I have pulled up. All that is the choroid. And then the back is the sclera, but it doesn't look white. It looks dark, and that's because the melanin has rubbed off on it. The melanin from the choroid has rubbed off on the sclera. Okay? But you have your 3 layers. You see your sclera here, the white. The dark next to it is the choroid, and then the beige that was on top was the retina. Okay, now, what do y'all notice here? Anything else that y'all notice in the choroid coat? Y'all don't notice anything in the choroid?
I thought it looked green, but I'm not sure.
Tell me again?
I thought it looked green, but I'm not sure.
You are correct. There's a section here that almost looks like a mirror. It's a very beautiful teal green, kind of yellowish gold. Okay? We don't have that. But animals who have night vision have this. It is called the tapetum lucidum. Tapetum lucidum. And I don't believe that's in your notes anywhere. But it's called tapetum lucidum. Any idea what this does?
Night vision, it gives them that green hueish, or they can see it.
Very good. We say
then-
deer caught in headlights. What do the deer's eyes look like?
It's that refraction
Kind
of the
of
light.
goldish or greenish. Even if you have pets, taking pictures of your pet when the flash hits their eyes, they don't get red eye like humans do. What do their eyes look like? Greenish, goldish, right? It's because of this structure. And when you guys all dissect your eyes today, walk around. They'll all look different. They will not all look like this. But normally, remember, the choroid coat is dark to absorb the excess light that comes in. Ours is really dark. We don't have that. But with animals who are out in the dark, they have to have a way to protect themselves, maybe escape from a predator or escape from a situation that may be dangerous. So they have to rely on whatever light enters their eye actually reflecting or bouncing back on those photoreceptors over and over and over again instead of just being absorbed so that they can find an escape route. That's what enables them to have night vision. This acts like a mirror, and the light bounces back on it and it comes back to the front of the retina, and so they can see better. They generate more action potentials. And again, it's called the tapetum lucidum. Okay? Tapetum. Lucidum. Tapetum or tapetum lucidum. Okay. I think that's all I have. I mean, is that everything, Lillian, if you're going down the list for the dissected eye? All this back here is the vitreous chamber, containing the vitreous fluid, pupil, retina, choroid. We've got all those. Okay? Yep, I think we're good.